Okay, welcome everybody. So at the start of this class, I told you that one of the questions I wanted to answer for you is how you can become a millionaire. And I was going to give you a surefire way, guarantee that you will become a millionaire if you take this class and pay attention. And so today I'm actually going to answer this. How can you become a millionaire based on whatever your salary is? And you don't have to be a business genius. You just have to follow this simple formula. And the key is that your savings will end up looking like this. This is an exponential function that we've seen before, and so these are functions that grow and double every 7 to 10 years, and so you get something that has this nice growth, and you can see a lot of growth happens towards the end of this curve. So we're going to take advantage of that phenomena. Okay, the idea here is that the slope gets steeper the further on you go. That's the key to this whole idea, is exponential growth. The slope gets steeper. Okay, so this is a practical assignment. What I want you to do is figure out what your estimated first year salary will be when you graduate from college. And if you need help with that, you can go and either click on this link, which will take you to the average salary for any college grad, so it doesn't matter what your major is. And apparently in 2019, students are expecting to make $60,000 when they graduate. That's not what they're getting. They're actually getting about $48,500 or at least, maybe $50,000. It looked like in 2017 it was $51,000, and in 2018 it was only $50,000. So that might mean that the economy is slowing down just a little bit, or that the market is getting saturated. I don't know. But let's start with that calculation. So let's assume that you're just an average college student with an average, good quality degree, and your starting salary is $50,000. Okay, so fill in that detail here, and then decide how much you can put aside. Financial advisors recommend you put 10 to 20% of your salary aside for savings every year. So I'm just going to take the 15%. That seems like a safe number. And then you can decide how much you think that you'll get in returns on your investments. So 7% might be something like if you put your money into a diverse portfolio of, in a 401k of index funds or stocks. The S&P 500 typically, its index fund usually gets around 7 to 8% over a 40-year period. So this isn't an outrageous. It isn't an outrageous bet. It's not guaranteed, but it's definitely a possibility. Of course, if you put this into like bonds or savings accounts, you're going to make less than that, but you'll have a more secure investment. But over the long haul, it's probably okay to put it into index funds, and you'll probably do better than 7%. But for now, let's just put it there, and you can always change that later if you want to be more conservative. Okay. So you have a starting salary, and that's what I put here. I just said that the starting salary is $50,000. And then I'm assuming that I'm saving 15% of that. So I'm taking, of the $50,000, I'm taking $7,500 that during the first year, and I'm putting that into savings. And then in the second year, I've supposed one thing. I've supposed that every year I get a 1% raise, a cost of living raise, and that's pretty conservative. You can see that if you just take that formula and drag it down, you only end up making $78,000 at the end of your career, and most people make much more than that by the end of their career. So 1% is just kind of a safe guess of what you might get for an increase. Oops, gotta undo that. I was supposed to drag down the second column, which is 1.01 times A2. So that's just a 1% increase. You drag that down, and you go up just a little bit, like $500 the first year, and then $505 the next year, and so on. And then again, this is just the savings percentage, which I set to 15%, times whatever I had in A3. So in this first year I saved $7,500. In the second year I saved $7,575. And if you add those up, you should get something like $15,575. But you can see I don't have that. I have $15,600. Why'd that happen? Well, I took the money that I had in C2, that was $7,500, and then I multiplied by 1 plus my interest rate, which is 0.07. So that's 1.07 times the 7,500. That's the money I made by letting this money sit inside of my portfolio. And then I added to it the money that I saved in year 2, which is the purple column, B3. Okay, so 7,500 times 1.07 plus 7,575 is 15,600. And then I take this formula and I just drag it down. So in year 3, if you look at the breakdown here, it's whatever I had in C3, which was what I've saved after 2 years, times 1.07, plus the money I saved in 4. The simple formula, right? And when you drag that down, you get these huge numbers, 2.429. That's how much money you'd have saved if you worked from 22 to 67 and you saved 15%. And that is also the numbers are plotted here in blue. That's the $2.4 million is essentially what I put here. And now if you look at column D, what I did here is what most people do is they might wait a few years before they start saving, because they're like, well, I'm young and I want to have some fun and I have student loans I need to pay back and everything, so I'm not going to put any money aside for the first 5 years. Maybe they even just save for the first year, but then one thing leads to the next, and all of a sudden they're at 28, like, oh, I haven't saved anything, I better start. And so you're like, well, no big deal, I've just lost out on like 54 grand, that's not a big deal. But you can see here that because exponential growth grows towards the end, the slope gets steeper the further on you get on the time axis, that you've actually cost yourself over $750,000 by just waiting those first 5 years. So that's a pretty big chunk of money that you threw away if you don't invest right away. Okay, so if you remember nothing else from this course, this is probably the most important lesson you've learned, is that just waiting and not putting aside a certain amount every year is going to cost you a lot of money. Okay, even if you can only do 10% per year, right? You save $5,000 your first year and then $5,050 your next year and so on, you'd have $1.6 million. And if you look at what happens if you wait 5 years, then you only have 1.1, so you've cost yourself $500,000 by waiting those 5 years. Okay, let me put this back to 15% because that's what I'd recommend you save. All right, now what I'd like you to do is to go and apply this, what you've just learned. Go here and look for what your major makes. Someone who is in your major. If you're a history major, you need to look up history. If you're a mathematics major, you need to look up mathematics. If you're math and computer science, you should look up that. And this just has all the top paying majors ranked, not just by salary, but also I think by how many you're actually making, close to the mid-career pay or whatever, and what the job outlook is. So they've ranked their majors based on pay and a few other factors. But you can scroll through here and you can see that if you want to become an actual mathematician, you're going to be making really good money by your mid-career. If you want to be a chemical engineer, you'll be making good money starting off and at the time you're at the mid-career stage and so on. Much more money than what we just calculated, right? But if you scroll through here and you want to figure out, let's see, what would be a good major to look at? English literature. If you're an English literature major, the average starting salary or early career salary is about $43,000. So let's just plug that in and see what happens. So you can go here and you can plug in the salary of $43,000. And you can decide how much you want to save. Maybe you can only afford to save 12% a year. And maybe you don't get 7%, maybe you only get 6%. Well, then that tells you that by the time you're 67, even if you're just an English major, you can make $1.25 or $1,259,000 if you just save 12% of your salary every year and you get an interest rate of 6%. If you're lucky and you can get 7%, then you'd have 1.6. And if you were really lucky, you can get 8%, then you'd have 2.2. I will tell you that anything over 8% might be a little unrealistic. I don't think you typically can ever get 10%. Maybe if you invest really well you can, but that's not the usual. But I can tell you that even if you're kind of conservative and you just invest in index funds and follow the S&P 500, you can definitely probably get 7%. I say definitely probably because there's no guarantees on the future. Okay, so go ahead and play with this. Put in your favorite starting salary. Maybe you can put in a different assumption and say that you get a 2% cost of living raise every year. Then all you do is plug that formula in, 1.02 times A2, and drag that down. And then you can see that rather than starting at 43, you might end up making $100,000. And then this whole calculation changes quite a bit. You end up with 1.9 even if we only save 12%. So there's lots of different variables you can play with here. I think the 1% is a more realistic number just because it's kind of conservative, and when you're doing these forecasts, it's probably better to be forecasting conservatively than outrageously. Okay, so if you take this and then maybe you just want to change your interest rate to 13%, you can see what happens. But go home, your assignment is just to go home, plug in your estimated starting salary, and then how much you're comfortable saving, and then tell me how much money you're going to make by the time you're 67 years old. Or if you want to change and retire at 60, then that's fine. You just need to chop off the last 7 columns here. So you need to be at like year 39 or something instead of year 46 or 45. I guess this is shifted down one cell. So this is year 45. If you want to retire at 60, then you're only working 38 years. So you go to this cell. You say, I'd have $1 million if I retire at age 60 with these assumptions. Okay, so go ahead and do that and tell me what you're going to make and how you're going to do it. If you're interested in setting up a financial plan, I recommend doing some reading. A really simple rule, though, is you just calculate your after-tax salary. So you take the starting number and you calculate your tax bracket, which we learned how to do on one of the first days of class. And then you follow the simple rule. You save 20% of your after-tax savings. You put that into your 401k or paying down debt or something like that, but typically you want to put it into your 401k. And then you have 50% as your needs. So that is, you want to take your after-tax salary and then put aside 50% for your groceries, your mortgage, your car payment if you have one of those, whatever things you would have to pay even if you lost your job. You want that to be at most 50% of your after-tax salary. And then that gives you the other 30% to go out and have fun. That would be things like eating out, going to movies, going on vacations, whatever it is you would do for fun. You still have that portion of money saved for like on a monthly basis to go out and have fun, go to the movies or do whatever. Okay, and you can see that I didn't make this up. I'm pulling this from a Investopedia, and they're getting this from Elizabeth Warren's book, All Your Worth. And so this is one of the things that I read and I followed when I set up my expenses when I got out of grad school, and I recommend maybe you spend some time looking into this as well. Okay, thanks for your time. Have a great day.